All right, guys, we're going to go on and pick up where we left off yesterday. I went on and filled in some of this here. I have a feeling there was probably a little bit more from the previous problem because we were kind of going back through and seeing what would happen or what we would need to do if it worked out the other two zeros weren't kind of nice numbers. And one of the processes is knowing that since 1 plus 3i is a solution, 1 minus 3i is also a solution, we got both of those setups equal to 0, multiplied them back together, and got the quadratic for which that works. Now that we have this, we're going to use long division to reduce the degree of the polynomial from 4 by 2, because it is a quadratic, and we divide the degree of what we divide by, reduces the degree of what's being divided by that amount. Degree 4 divided by degree 2 will result in a degree 2. And if we do the steps for this here, first step's to see what times x squared will give us x to the 4th. Well, that actually works out to be x squared. Interestingly enough, I wrote all this down, and then I'm going to immediately erase all of it because I'm going to provide myself a little bit of room to work, because we'll do x squared times x squared minus 2x plus 10, and when we distribute this out, x squared times x squared is x to the 4th. X squared times negative 2x is negative 2x cubed, and x squared times 10 is plus 10x squared. Or cubed x squared. And then our next step is to subtract. X to the 4th minus x to the 4th is 0, which is exactly what we wanted. Negative 3x cubed minus negative 2x cubed. Negative and negative make a positive. Negative 3 plus 2. Negative x, because 2 minus 3 would be negative 1. Negative 1x cubed. 6x squared minus 10x squared would be negative 4x squared. And then we bring down our plus 2x. And we repeat the process. What times x squared gives us negative x cubed? Well, we know exactly it would be negative x, because it is positive, but we need it negative, and we need an x. So now we're going to multiply our statement by negative x. So our x squared minus 2x plus 10 multiplied by negative x would give us negative x cubed plus 2x squared minus 10x. And then at this point we would subtract. Negative x squared minus negative x, or not squared, negative x cubed minus negative x cubed is indeed 0. Negative 4x squared minus 2x squared would be negative 6x squared. 2x minus negative 10x, negative and negative make plus, giving us plus 12x. We bring down the negative 60. And lastly, what times x squared gives us negative 6x squared? Negative. Yeah, so negative 6 times our x squared would indeed give us negative 6x squared. And one last time, if we do the multiplications, we do get negative 6x squared plus 12x minus 60. Now we do expect this outcome of the final expression, because when we subtract, all three of these become 0. And that is the expected outcome, because we know that our 1 plus 3i, 1 minus 3i are both solutions. So the quadratic x squared minus 2x plus 10, which gave us those solutions, should be divisible by our starting polynomial expression, which means they will divide evenly. At this point here, get rid of the scratch work. The last two that we have to solve for is our x squared minus x minus 6 is equal to 0. Now at this point here, we could use quadratic formula, completing the square, factoring, graphing. And since we already know what the answers are going to be, we could have graphed it and saw, hey, they do cross the x-axis at 2 nice points, and we have our solutions. Or we can go on and factor it, 2 sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite. Factors of x squared are x and x. Factors of 6 are 2 and 3. And it ends up being x plus 2 and x minus 3. Two things multiplied together to equal 0. Well, one of them must be 0. So x is equal to negative 2 and x is equal to 3. So those are our other two solutions with our 1 plus 3i and 1 minus 3i. So we kind of see how we got there this other way. Questions on this here? Find all the zeros of this here, given that 4i is a zero of the function f. Well, if x is equal to 4i, x is also equal to negative 4i. I thought about showing you all this with the last one, but I'm going to show it to you with this one here, because there are two ways we could go about doing this. One of them, as we saw in the last one, and we did this before, is we could graph this and see if the other two solutions are nice numbers. If they are, we have all four and we're done. If not, the last way we did is we got both of these equal to 0, multiplied them together, found our quadratic equation. Use long division with that to simplify this expression down. And in this case, it wouldn't go down from a degree 4 to a degree 2. It would go from a degree 3 to a degree 1, and we'd get our answer. Now, looking at this here, since it is a degree 3, we should have 3 solutions. We should have 3 solutions, degree 3. And how many do we have so far? 2. Now, that tells us something very important. It tells us that the other solution is not going to have an imaginary number. Because all imaginary solutions, solutions with I, have to have a conjugate. If we have one, we have to have the other. So they always come in pairs of 2. Well, we only have one solution left, and that solution cannot be a complex number. It also means it can't be irrational. It can't have a square root that doesn't reduce. Because just like with complex numbers, irrational numbers, our square roots, also come in pairs, which means it can't be one of those. So more or less what this is telling us, in that it gave us 4i as one of the solutions, it means whatever the other solution is has to be rational. It has to be a fraction. It's either going to be an integer or a fraction. This is kind of what we're left with. Now, I'm going to show you something that is interesting. Synthetic division does work for these. And we don't have to do any multiplication. We don't have to do any of the stuff we did for the setup for long division. And what we can do is put in one of the solutions into our box, 4i. If it gave it as a factor, x plus 4i, we would have to solve for x, and then we can put it in here. The numbers across the top are the coefficients for our polynomial. 3, negative 2, 48, negative 32. And we get those here. Now, if there's any terms missing from our original statement, so we had x cubed, x squared, x constant, if one of those is missing, we plug it in as 0. And now we can start the steps for synthetic division. And the first thing we do is bring down the 3. Our second step is to multiply what's inside the box by our 3. So we would do 4i times 3, 12i, and put it under our next term. And at this point here, we add straight down. Well, negative 2 and 12i are not like terms, so it'd just be negative 2 plus 12i. Now, most don't show or teach this method because, well, the first one's nice. 4i times 3 is 12i. We add, we get 2 plus 12i. Now, it gets a little funky at this point because, again, we're going to repeat the process. We're going to say 4i times, in this case, 2 plus 12i. And if we multiply these out, 4i times negative 2 is negative 8i. 4i times 12i, 4 times 12 is 48, I squared. I squared is negative 1, so it's really just changing it to negative 48. Luckily for this one here, we don't have any like terms to combine at this point. So what we have is negative 48 plus, not 12i, not plus. We place it underneath it, and if I can remember the correct statement, minus 8i. I did rewrite it so that it is in standard form, a plus bi. So we get negative 48 minus 8i. Add straight down. Well, 48 plus negative 48 is 0, leaving us with negative 8i. And lastly, we're going to do 4i times negative 8i. 4 times negative 8 is negative 32, and I times I is I squared. Well, the I squared is negative 1, which is going to turn it from negative 32 to positive 32. Add straight down. Negative 32 plus 32 is 0. The last number under the line is the remainder, which tells us for this here that 4i divides into this evenly. Questions on this so far? Now, that's one of our solutions. We did have a second solution, yes? Which was negative 4i. We're going to do this again, but with negative 4i. I'll do this one in red. So our first step is going to be negative 4i times 3, which is going to be negative 12i. Because it seems like it would be 12i, but this time the 4i is negative, so we get negative 12i. And what's interesting is after doing the second one, if we add these two together, negative 2 plus 12i plus negative 12i, the 12i and negative 12i become, leaving us with negative 2. And now this one here, we only have to do one more. Negative 4i times negative 2. Negative 4 times negative 2 is positive 8i. And lastly, negative 8i plus 8i is 0. So after applying both of our complex solutions, we get this here. And if we remember how to plug the variables back in, the last number under the line, the one that I put a box around, is the remainder, just like with the previous one. The number to the left of it is the constant term. The number after it is x to the first. And then if there was a number after that, it would be x squared, x cubed. We just keep increasing the power. So after dividing that, what it tells us that we have is the expression 3x minus 2. This contains the last solution. So we need it set equal to 0. And at this point here, it is kind of nice. Because to solve this, the first thing we can do is add 2 to both sides, telling us 3x is equal to 2. And lastly, we would by 3, telling us x is 2 thirds. So our solutions are 4i, negative 4i, and 2 thirds. Questions on this here? And in some ways, I think this is a little bit nicer and not nicer at the same time, because I do think it's nicer in the fact that we don't have to get x equals 4i and x equals negative 4i equal to 0, multiply them back together, simplify that down, and then do our division process. We can go straight into the division process and start simplifying. Also, if we tried to have graphed 3x cubed minus 2x squared plus 48x minus 32, it would have shown us the solution, but we would have had to instinctively known what 2 thirds would have been, or use other processes to see that the graphing calculator told us that the x value was 0.6 repeated, or 666, and then a 7. Okay, that's interpreted as 2 thirds, and we could go from there. Now, for the most part, I think most of us can recognize 2 thirds because the 0.6 repeated, but some of the other fractions that are not nice, 0.75, 0.25, are nice decimals, are not as instinctually obvious as in 5/13. We're not going to just immediately recognize that 0.384615385 is 5/13, and that's understandable. It would take me quite a while to get there. It would be a lot of trial and error trying to see what it could be. And there's tons of them that don't work out to be nice, recognizable decimals. But there are some that people recognize. Questions on this here? Find a polynomial with a given 0. So this here, if we feel good with this here, I will, if we do have time, go back and show you this one, especially doing that other way we just did, because it is a little bit interesting. We do have a few more factors to multiply, and we can see it if we have time. I think we will. But this next one, I know it's your sheet's not written this way because I went to the next slide that doesn't have the extra information given. But what it's asking here is to find a 4th degree polynomial function with real coefficients that has -1, -1, and 3i as zeros. Now, normally in a lot of these here, it's saying find least degree, but we work through. Now, the second set is saying, well, if 3i is a solution, -3i is also a solution, and we need to get it in linear factored form. Now, to do this, really the first main step, and kind of one of the steps they more or less skipped over, but it's kind of understandable, it's setting it up kind of like this here. We're saying that x is equal to -1, x is equal to -1, x is equal to 3i, and x is equal to -3i. That's kind of what it's saying. Now, as we did on the other problem, we're going to get all of these equal to 0. X plus 1 is equal to 0. Here we're going to add 1, telling us, well, x plus 1 is equal to 0. Here we're going to subtract 3i, telling us x minus 3i is equal to 0. And lastly, we're going to add 3i, telling us x plus 3i is 0. I think at this point we feel pretty comfortable doing this. It's just doing the opposite operation to get them onto the other side. Now we're going to multiply them all together. Now we can have the equal 0, or we can leave it off. Either way, we're really just wanting to see what do these four binomial expressions multiply together to give us. One thing that I would advise heavily against is trying to multiply one of the complex linear expressions by something other than its pair. So I would definitely multiply these two together for sure. I would not multiply the x minus 3i and the x plus 1 together. It is possible. It is doable. You will get the correct answer doing it. But in the long run, we do end up getting more terms, I terms, that eventually do cancel out, but you're having to keep track of them over a longer period of time. The more factors that we do have of these, the more I terms we get, and it makes it easier and easier to make a mistake somewhere along the line than it is to just multiply them together in the beginning. Because if we do these here first, x times x is x squared. X times 3i is plus 3xi. Negative 3i times x is negative 3xi. And negative 3i times 3i is negative 9i squared. And before we do any other multiplication, 3xi, negative 3xi, 0, they're gone. Negative 9i squared, I squared is negative 1. And negative 9 times negative 1 is positive 9. As we can see here, all the I terms are gone. One easy step, they're all gone. And that's nice. Now normally, especially in Algebra 2, we would rewrite the x plus 1 and x plus 1 because we only do one set of multiplication at a time. But at this point, I think we're comfortable. We did the multiplication step. I can move over here and do the same thing. X times x is x squared. X times 1 is plus x. 1 times x is plus x, and 1 times 1 is plus 1. Now we can combine like terms here. We have x squared plus 2x plus 1 being multiplied with our x squared plus 9. And lastly, we're going to multiply these out. X squared times x squared is x to the 4th. X squared times 9 is plus 9x squared. 2x times x squared is plus 2x cubed. 2x times 9 is plus 18x. 1 times x squared is plus x squared. And 1 times 9 is plus 9. X to the 4th, x squared. X cubed, x squared, 9. Yes. And the last thing we need to do is combine like terms. X to the 4th does not have any like terms. Now it's tempting to go to x squared next, but we always decrease in power. So 4th, the next one would be 3rd. Would be our plus 2x cubed. Now we would do x squared next. 9x squared plus x squared is 10x squared. Then we have plus 18x plus 9. And this would be our answer. If we wanted to, we could say f of x is equal to this here. But this is the polynomial, the 4th degree polynomial function with real coefficients and a equal to 1, or the leading coefficient being 1. Because I could generate any other ones from this, because I could multiply the whole thing by 2, whole thing by 3, whole thing by 4. and I would still have the same solutions, and it'd still be the true equation, but this is the one we want. We don't want to start messing with the value in front of x to the fourth. So we get this here. Questions on this here so far? I think that leads us to the last one. Find a fourth degree polynomial function with real coefficients 2, -2, and -7i. Now the first thing we need to do for this here is, well, we can set it up. X equals 2, x equals -2, x equals -7i, and well, x is equal to 7i. Now we can get these equal to 0 to find, well, really equal to 0, or we're finding the linear factors for each one. Which we can do by setting x equal to them, then getting it equal to 0. And then multiplying all of these factors together. Now if we do the x minus 2 and x plus 2 first, x times x is x squared. X times 2 is plus 2x. -2 times x is -2x. And -2 times 2 is -4. Now this is going to work out kind of nicely because our positive 2x and -2x become 0. We can do the same thing with our other set of parentheses. X times x is x squared. X times -7i is -7xi. 7i times x is plus 7xi. And 7i times -7i is -49i squared. -7xi plus 7xi is 0. Our I squared is going to turn that from -49 to positive 49. Telling us that this, when simplified, gives us x squared minus 4 times x squared plus 49. At this point here, we're going to distribute x squared times x squared is x to the fourth. X squared times 49 is plus 49x squared. -4 times x squared is -4x squared. And -4 times 49 is going to be negative, well, -196. And that's it there. Questions? Questions on anything we've done so far? We good? Here is the homework assignment. So I'm going to look back at this one here. If we had done this one using synthetic division instead of multiplying, 1, -3, 6, 2, -16. Now for this here, I would suggest giving yourself a little bit more room between each numbers, because when we do the multiplication, the first one's kind of nice, because we have 1 plus 3i being multiplied with 1. which is 1 plus 3i. And all of these here, we're going to end up having 2 terms every single time. Now we do have some like terms here. Negative 3 plus 1 would be negative 2. But we still have our positive 3i. So when we do our next step, 1 plus 3i times negative 2 plus 3i, we do have to do some distributing here. Now, we don't necessarily have to do this by hand. I'm going to do this one by hand. Then we can show you another way. We would distribute the 1. 1 times negative 2 is negative 2. 1 times 3i is plus 3i. 3i times negative 2 is negative 6i. And 3i times 3i would be plus 9i squared. Well, the I squared is going to turn this from positive 9 to negative 9. Negative 2 minus negative 9 would be negative 11. 3i minus 6i is negative 3i. And again, just like the previous one at this point, we add straight down. 6 plus negative 11 is negative 5 minus 3i. Now the 3i, as we've seen in both, stayed the same in both cases. Well, that's because with the negative 3 and 6, we don't have a like term with I, and since we're adding, it's not really changing anything. Next step. Now we're going to multiply our 1 plus 3i with negative 5 minus 3i. And as I said on the previous one, we don't have to do these by hand. Graphing calculator. Clear all that out. We can do 1 plus 3i times negative 5 plus 3i. No, I think that's it. Negative 5 minus 3i. Negative 5 minus 3i. Enter. The graphing calculator will do this multiplication for us. 4 minus 18i. And again, just like the previous one, we're going to add straight down. Well, 2 and 4 would add together to give us 6. So we still have the minus 18i. And lastly, we're going to do this multiplication one more time. We're going to have 1 plus 3i times 6 minus 18i. Now the reason I put 60 down is because we know this should divide evenly. Our last number is negative 60. This should give us positive 60. So let's go on and do it just to make sure. 1 plus 3i times 6 minus 18i is indeed 60. And again, if we add straight down, negative 60 plus 60 is 0. Since 1 plus 3i was a solution, 1 minus 3i is also a solution. I'm going to erase all this here so I have extra space to work. And we're going to do this process again. But this time we're going to do 1 minus 3i times 1, which is 1 minus 3i. And luckily enough, with this one here, I did this earlier today, we actually don't even need the calculator at this point. Because if we add these straight down, negative 2 plus 1 is negative 1. Okay. Negative 1. Positive 3i plus negative 3i is 0. So we have negative 1. Okay. So our next one is 1 minus 3i times negative 1. 1 times negative 1 is negative 1. Negative 3i times negative 1 is plus 3i. Again, add straight down. Negative 5 plus negative 1 is negative 6. Negative 3i plus 3i is, again, 0. So now we need to do 1 minus 3i times negative 6. 1 times negative 6 is negative 6. Negative 3i times negative 6 is plus 18i. Six plus negative 6 is 0. Negative 18i plus 18i is 0. Now at this point here, we can fill our information back in. The last number, the one we always put in a box, I always put in a box, is the remainder. The number in front of it is the constant term. The number in front of that is the term with x, and the term in front of that is the term with x squared. So what it tells us is that we have x squared minus x minus 6 is equal to 0. And just like we did earlier, we can continue solving from here. X minus 3, x plus 2 is equal to 0. X minus 3 is 0. X plus 2 is 0. We would add 3 for this one here. Subtract 2 for this one here. Telling us x is 3 and x is negative 2 again. So in some ways, I think this here is a little bit nicer. In some ways, it's not, because we do have multiple terms to keep track of. But it is a little bit quicker than having to hit the linear factors, multiply them together, get the quadratic, and solve it from there. But either way works. But that is the end of that one.